Hello physical science students, welcome to the 5th video in electrical energy. This time we're going to be looking at measuring current and voltage and as a consequence resistance. So we use meters to measure these, but the meters must be connected in a particular way, and I've mentioned the meters before, but we'll just quickly recap what they are and how they're used and how they should be connected. Now the first one, for measuring current, we use an ammeter. An ammeter reads amps. Amps is to measure current, therefore we use an ammeter to measure the current. And it's got to be in series. So here's our symbol for an ammeter, and it will measure the current in this circuit. Now we could have just as equally put, is that drawing? Yep. Geez, there's a bit of a lag. We could have put the ammeter there, or we could have put the ammeter there, or we could have put the ammeter there. You're getting the idea? Could be anywhere, because and all these ammeters would read the same current, and they would also have very little effect on the circuit because they basically have very little resistance, so it's almost as if they're not there. Get the idea? So that's an ammeter, and we'll hopefully get to use an ammeter when we do some pracs. Okay, now for measuring voltage we use a voltmeter. There you go, it measures in volts, it's a voltmeter. Now a voltmeter is a little bit trickier than an ammeter in that it's got to be wired in parallel, and when it's wired in parallel it will only measure the component for which it is parallel to. So it measures the potential difference between the 2 points which it is connected to. And so here we have a circuit with our batteries, and if we remove all these voltmeters, it's a fairly simple circuit with 3 light globes in series. And we've put in 4 voltmeters, and each of these voltmeters measures a different thing. This voltmeter would measure the voltage or potential difference produced by the cell or the battery. This voltmeter would measure the potential difference across that bulb, this one across this bulb, this one across this bulb. Okay, and as you can see here, this voltage is the supplied voltage, and so all the other voltages of all the other components add up to give that. So if this was 12 volts and these were identical bulbs, you would expect this to be 4 volts, 4 volts and 4 volts. Is that right? Yeah, adding up to 12 volts. There you go. Okay, so now in terms of resistance, we don't have anything to measure resistance, but if we have a voltage and we have the current, and we get those from using a voltmeter and an ammeter, we can calculate the resistance. For example, we could calculate the resistance of this bulb if we knew the voltage here and we had an ammeter for the circuit, because remembering in this circuit it's a series, an ammeter anywhere in this circuit would give us the voltage through this bulb. So that's how we do that. Now in the modern world, electricians don't use different meters for different purposes. They use what's called a multimeter, which just can be flicked between an ammeter and a voltmeter, and much more useful. Alright, so in the next video we're going to look at what's called Ohm's law. See ya.